Hello, everyone. Allow me to introduce the speaker for today. Pei Seng is experienced in computer vision, text analytics, reinforcement language learning, and web application development. He has a bachelor's degree in Mechatronic Engineering from Universiti Teknologi Malaysia, UTM, and a master's degree in Data Science and Analytics from Universiti Sains Malaysia. He's also a technical writer in medium under publishers, namely Towards Data Science, Better Programming, and Data Driver Investors. Pei Seng is also HRDF TTT Certified Trainer. He organized more than 15 technical workshops at USM, UTM, TARUC for the past 3 years. One of his accolades is being appointed as a Gold Microsoft Student Partner MSP in the year 2019. The grants sharing session that he has recently contributed includes Barcamp Cyberjaya 2020 on August 2020 and MSP Asia June Meetup on June 2020. Without further ado, Pei Seng, the stage is yours.
Hi everyone. Let me share my screen first. Jay, can you see my screen? Should be fine, right? Okay. So, okay. Good afternoon, everyone. Yes, thanks for coming for this session. I'm the speaker for this session, which so today I'm going to talk about natural language processing with classifications. So basically, what is natural language processing, which we call as the NLP? So the definition basically is ability of a computer program to understand the human language as is spoken. So which means that natural language normally is produced by human, and then we have to let how the computer are going to understand human languages. And there are 3 stages in the NLP, which is called, the first one is called symbolic NLP. So it's starting from 1950s, and then next will be the statistical NLP. So it's starting from 1990s, and now it's getting popular. It's called a neural NLP. So starting from year 2010. And symbolic NLP is basically a rule-based method. So basically we assign the rules. This is a very hardcore methods. So allow the computer to pick up and process the natural language. Whereas for statistical NLP basically are using the statistical approach, basically using something like t-test and all this, basically just to process, to validate whether the human the natural language is interpreted correctly. Okay, whereas for neural NLP, basically the back end is a neural network. Okay, in order to have in order for you to be good in NLP, so basically you need various field of the knowledges. So the first one is basically AI or machine learning, and the second one is statistics, and the third one is information extractions. So what the information extraction here means is that we have to extract the relevant facts and also relationship from the unstructured text. So for example, like the sentences like he looked handsome. So the information that we are trying to, the rules that we can try to get from these sentences is that we know that he basically it is nouns, whereas for looks is basically is verbs, whereas handsome is represent adjective. Whereas the fourth one, which is called concept extractions, so is basically I want to study the meaning of the particular words. I want to extract the meaning of the particular words. For example, like child and infant. So what the concept extraction inside, what they are doing is that we are trying to group the word and phrases into a similar group based on their semantic meaning. And then lastly will be a computational intelligence. So in order for you to good in NLP, basically you need this knowledge. Okay, next. So in the title, I mentioned that there is natural language processing and with classification. So the classification here basically means that I want to classify the data into groups. So it should be a class A or it should be a class B in this case. So what we are trying to do in the classification is that we are trying to draw this line Okay, so that we're able to clearly separate it between the classes. The blue dot represent the class A, and then the triangular represent the class B. Okay. So in terms of the application of NLP, there's actually quite a lot. So the first one is called machine translation. Machine translation basically is to translate from one languages to another languages. For example, today you want to translate from English to French or from French to English, and this we call machine translation. And the second is the information retrieval. So I think I mentioned just now, basically I want to know the informations for a particular sentences. And then next will be the sentiment analysis, which we are going to be heavy focused for today. And fourth one will be the information extractions. So I'm trying to extract the informations, okay, from a particular sentences. And lastly will be a question and answering. So basically, for example, I try to ask a question, and then after that, I want to see whether the computer able to give me the correct answer. Okay. So today we are going to focus more on the sentiment analysis. And what the sentiment analysis does is to basically I want to study the semantic, okay, the meaning of the inside for particular sentences, and I want to guess what is the semantic inside. For example, it should be a positive, or it should be a negative, or it should be a neutral. Okay, so for example, like these sentences, I have a totally dissatisfied with the services, worst customer care ever. So when I read these sentences, so it should be a negative. Okay, so for example, I read the sentences like, have the brilliant effort, guys, love your work. So when I put these sentences into the machine, so it should be able to tell me that, oh, these sentences actually encoded with some positive sentiments. Okay, so before we go further, actually we need to know what is the workflow for a normal machine learning project. So the traditional workflow will be, first I'm trying to get the data, and then after that I'm trying to clean, to prepare, and also to manipulate the data so that it can be used for modeling. And after that I train the models and evaluate the model, and lastly I try to improve the model. So if I cannot further improve the model, then I will try to deploy it and close the project. Okay, so basically this. So how I'm going to apply this machine learning project workflow into the sentiment analysis is that, okay, for example, it is almost the same. Okay, for example, like first I will have the text input. So basically I'm trying to get the data. Okay, so after I get the data, so next I'm going to clean my data, manipulate my data, and even transform my data. So the sum of the pre-processing skill that you need, for example, you need tokenizations. So what the tokenization does is that, for example, like these sentences, I am hungry. So it's a full sentences in string. So when I tokenize, actually I transform it from a string into an array where it contains one words, okay, will be one items inside the list. Okay. And then next we got another processing method called stop word filtering. So for example, like these sentences, to eat the fruits. So when we say to eat the fruits, so the to and the actually does not contribute a lot of meaning, okay, inside us for sentiments and during the sentiment analysis. So so due to this application, we need to remove the word to and also the. So for example, the eat and fruit, because if we remain this word, right, so because every sentences probably you will have the probability to have the two words is a lot, and then it will make, it will increase the frequency of the words, okay, to two in, the number of words will be increased in a particular passage. So the problem here will be, this one will have a higher frequency and become a very significant noise. So for what we can do in the text processing is that we try to remove these common words which does not bring a lot of meaning to the particular sentence or particular sentiments. Okay, and next we have a negations handling. So the negation handling is that, for example, for this sentence, like this movie wasn't that good. Okay, and then sorry, there's typo here. Actually, it's the movie wasn't that bad. So when human reach when human read these sentences, right? So you won't have the do you feel very confused? So for example, like the movie wasn't that good. So actually, it's good or not? Okay, but for machine, you will have some problem in recognizing this because you have the verb of good, okay, and then you have the wasn't there. So is it good or not? Okay, so for these cases, probably you need to handle it. Okay, so this called negation handling. And lastly, the last processing method here is stemming. So stemming basically is, for example, like I got the word studies. Okay, I'm trying to reduce some of character to reduce try to become the roots. Okay, for example, like studies, I try to reduce the es, then become study. So why this is very important is because, for example, okay, you have a present tense, past tense, for example, like eat, ate. So in this case, actually, it represents the same. It actually semantically they are the same. Okay, the meaning they are actually the same, but because of it's past tense and one is present tense, so you got the issue in to interpret it, but the semantic meaning actually is the same. Okay, so we need to address with this issue. And then next, after we pre-processing our data, then we are going to train our model. So classification, it can be just a simple algorithm like SVM, it can be a random forest, or it can be just a logistic regression and so on. And even you can introduce a deep learning framework like CNN, RNN, or LSTM, and so on. Okay, so this is classification. And lastly will be sentiment class. I want to predict what is the class, what is the sentiment class. For example, it should be a positive, or should be negative, or even neutral. Okay, so today I'm going to introduce this session with a case study. So basically, we are going to doing a Twitter US airline sentiment analysis. So we are going to build a classifier to help us to automate the task of analyzing the sentiment of the particular sentences, or whether it should be positive or negative. So the example of the tweet will be like that. Okay, you have a lion, Virgin America. Then we got seriously would pay 30 ringgit at a flight for a seat that didn't have this plane. Okay, so probably when you tweet, right? So you are trying to post a tweet, okay, to make a complaint. So from there, the airlines company basically they collect this tag, this tweet, and then they try to analyze what their customer are complaining about, or they are not. They feel that they try to improve their service, okay, from that. Okay. So this is basically the example of the tweets that coming out from Twitter, and we would like to classify whether it's a positive or negative tweet. Okay, so in order to make this success, I have separated the process into a 4 steps. So the first step basically is just a business and data understanding. So before you start a normal text analytic project, or you start a machine learning project, basically you need to know what is your end goal. So the end goal for this, for my business, basically is just to create a classifier that can automatically predict the types of tweet sentiments. Okay, so it can be either positive, negative, or even neutral. And next, I would like to understand more about my data. So where I got my data? So I got my data from Kaggle. So as you can see, actually I got it from here. So in future, if you want to try this data set, you can just download directly from Kaggle. So basically, I got it from here. Okay. Yeah. So next, so after you know my my data source, which is from Kaggle, and then I would know what type of file I have. So basically, it's a CSV file. Okay, so and then you have to know how we are going to load the data out, and also how to visualize the data. Okay, so I have prepared a script, okay, for purposely for this session. So basically, later I will show you where you can get this. Okay, so I actually running on Colab. So so the first thing is, okay, so I'm going to use the pandas library to load my data because it is a CSV. So this line of code basically just to import the library. After that, I upload my data set onto the Google Drive. So what I do is I try to connect to Google Drive, and then after that I try to call the Colab to read the file, and then to access the file, and then after that I call my library to read it. So basically I using some Python library, which is pandas, to help me to read. So this is how the data look like. So basically we got a Twitter ID, and then there's some null value, and then we got airline sentiment. So airline sentiment is the things that we are really focused, is because we only got 3 classes, which is negative, positive, I don't show positive here, and even neutral. Okay, and then here got other data because we are doing the text sentiment. So I think it's not really this data is not really useful for us until this column. So we are trying to looking this for columns. This is basically all the text, okay, that we want to process. Okay, so now we already roughly know what type of data we have. Okay, so what we can do is next we are going to visualize the chart. So basically I visualize using a Matplotlib library. Okay, so if you are familiar with Python, probably you know what I'm talking about. So it's okay. So before I start, I try to study how many sentiment that I have and their types. So from this diagram, so I explore my data and I know that the negative sentiments is there's a highest number, which is 5758, and then neutral is 3099, and then positive sentiment is 2363. So at here probably I'm going to predict I'm going to face some imbalance data issue probably. Okay. So next, then yes, now I know my how my data look like. So next, I'm going to pre-process or prepare my data for training. So, okay, so let's go to mode. Okay, so in the second step, basically, it's called data preparation. So I'm going to clean my data, manipulate the data, and also transform my data. So for example, so this is my samples tweet. So after going through the data preparation process, it should become a list of the float so value. So why I want to convert it to float value is because computer cannot like human recognize text. So what they recognize is actually numbers. So we have to transform the verb, all the words into a numbers. Okay. So what is the pre-processing technique that I use? Okay, include first, because we got that there are too many columns here, right? So the first thing is I want to drop the other columns that I do not need, or even I just select the columns that are required. Okay, so the first thing is I select the required part of the data. Okay, after that, then I review some MP review because there are some columns are MP, which that make no sense for me, so I just drop it. And then the third step will be I try to convert all the review to lowercase. Okay, because why I convert all the review to lowercase, because the big capital of USA and also the small capital of USA actually most of them actually are same. Okay, so what I'm doing here is that there's some big capital, so I convert it into all characters into lowercase, so like this. So this is basically the output. Okay, and next I try to remove all the numbers. Okay, so how the method that I use is basically I use a regular expression. So basically just a technique to search a pattern. So for example, this pattern I trying to search is /d. So /d actually represent characters. It can be a character, and then it should be a character from the range of 0 to 9. And then the plus here means that it can match one or more characters. Okay, so in this case, I'm trying to replace all the character with all the characters which are 0 to 9 that match basically match this criteria, or they become a MP. Okay, in this case become an MP words. Okay, become an MP content. And then the next, I also remove some Twitter account, for example, like this alliance. Okay, so this alliance just tell us the airline's name. Okay, so like US Airways. So this is basically the airline's name. And then this is also another hash. Okay, for me, I feel not really important. Okay, so that's why I try to remove it. Okay, the whole sentences. So after I remove it, so you will look something like this. Okay, but it's still not really satisfied because we got some special character and then some maybe of space and so on. So we can further remove, using a regular expression to help to remove. For example, we remove the website URLs, and then we remove the special characters and even remove the white space. So all this here basically I'm using the regex expression. And then next, so the step 9 basically I use a text normalization. So for example, these multiplications, multiplicatively, okay, blah blah blah, all these actually they share the same root words, okay, which is multiples, okay, which is multiple. So when I saw this word, using lemmantizations, it will help me to reduce the words into a base form. Okay, so for example, we got eat, eats, then add, okay, eaten. So all these will return to the base form, which is eat. Okay, like this case. And then so here, so this is basically the standard lemmatization methods. And lemmatization with part of speech. So what is part of speech? So when I lemmatize, I can choose whether I want to input other information into it. So in this case, because I just set one as default, so the default is actually yes for this one. So what I'm going to do is I'm going to pass the part of speech information in. So how I'm going to pass the information in is that first, okay, for example, so what type of information I'm passing in? Basically, I tell the lemmatizer, okay, whether this word should be a noun, or it should be a verb, or it should be a adjective, and so on. Okay, so for example, like these sentences, Bob made a book collectors happy the other days. So you break it down, actually Bob is a noun, okay, made is a verb, okay, a book collector, so A is articles, B is adjective, and then C is noun. Okay, and then we still got a verb, happy is the adverbs, okay, the other days, okay, the is articles, other is adjective, and day is nouns. Okay, so I pass the sentences together with the part of speech tagging information in to the grammatizer, and then it helped me to reduce the word into a base form. Okay, and next, so and in the beginning I mentioned there's a lemmatization and also stemming, and both of them are actually similar, but there are some different. For example, like this word. So for the word was, okay, if you're using lemmatization approach, basically you will just get the base word, basically it's just be, okay. But for stemming, right, it will just cut the s. Okay, when you see the s, then you will cut the s, because for example, like apples, okay, apple, so you got s. So when you're using stemming approach, it don't care what is the base word, it just cut, okay, it meets some criteria. For example, there's s behind, then it's just slash s. So if you're using stemming approach, was, so it will reduce back to wa, okay. And then so studies, so it's also see different lemmatization. It can clearly reduce back to the base word, whereas stemming cannot. And then you might have a question, since stemming is not accurate, why I want to use stemming? Okay, so the reason is just stemming is faster. Okay, stemming is just faster, and lemmatization, it takes more times than stemming, but it's more accurate. So it depends on your application. If your application thinks stemming, you want a much more faster solution, probably you can use stemming. And then if you require more accurate solution, then probably you need to use lemmatization. Okay. Okay, and then the last two. Okay, so not last two. Okay, so the next technique I'm going to use is the text augmentation. Okay, so why I'm going to use a text augmentation is because in the beginning you saw that the positive sentiment. Okay, the class there's a least samples. So I'm trying to do upsampling to solve the issue of imbalanced data sets. So what I'm going to do in the text augmentation is that, so I'm trying to change the word with synonym. Okay, for example, the perception that I took, so I change the image I extract. Okay, so this is the way how I'm going to enrich my data set so that my my model are able to make well predictions. Okay, so this is one of the method to increase the number of data set. Or if you have an imbalanced class, okay, you actually can use this technique, okay, to try to make your data set more balanced. Okay, and then after that, so okay, I think I show you the code first before you go blur. Okay, so I think just now we are here. So next we prepare the data set. Okay, right. So first we select the required column. So we got a lot of column here. So basically what we are going to do is we are going to select two columns. So basically this is the labels and then this is the text. Okay, and then I'm going to combine these all operations into a functions. Okay, and then after that I run the code. So as you can see, the original text is a lion, Virgin, America, what different state. Okay, so after you change the sentences, after you flow through the this one is called what? Clean text function. So basically, I perform all the operation here, and then I'm basically able to get more clean data. So I just remove until what say. Okay, so for example, the second sentences, the Virgin America plus you have added commercials. Okay, so I already remove this. Okay, so plus you have added commercials too. Okay, so I'm trying to clean the text to be more pure so that it's easier for the model to do prediction. Okay, and next I'm undergoing the text normalizations. So this is how I initialize the text. So basically first I import the library, and after that I download the some files that are required. Then after that, I initialize the WordNet lemmatizer. Okay, and then after that, I pass the information of the post here. Where is it? Here. Okay, so basically, I will pass the information of text and also the WordNet. The tag. So the tag is that, okay, if this word is adjective, so we are going to saying that this is adjective. Okay, if this word is nouns, then we are going to pass the information saying that, oh, this word is noun. Okay, so we are going to pass into the lematizer, and then this is the output. Okay, differences. So for example, like what say. Okay, so the output will be what say. Okay, so I able to reduce the word back to the base form. Okay, so we go to which sentences. Okay, here. So well, I didn't, but now I do. Okay, so if you change to, after you pass through the text normalizer, so you get, well, I don't, but now I do. Okay, so this is basically the output. So this is basically the functions of the word text normalizer. And then after that, so I'm going to upsamples my dataset because I found out that my dataset here is not balanced among the class. So I'm using the synonym, okay, here. So I'm using the NLBlock augmented word. So basically just a diction, it's a library to help me to create some synonym to replace some of the words. Okay. After I call the library, then next, so I got more positive samples. Okay, because here basically I initially saying that I want to have 2 positive. Okay, I want to have positive 2 times. Say the original times 2, the original number times 2. So the operation inside here basically it includes like I select the targeted columns, and then I initialize the augmenter, then I initialize the ratio of sampling, and then I perform the upsampling task according to the settings. Then after that, I return the sample dataset. Okay, so this is how the function to be initialized, and then after that, I just let the data frame to flow through this function, and then I get a data frame containing the text that is augmented. Okay, and then after that, I show the count. So basically, okay, so I get more positive sentiments. Okay, hopefully you are clear. Okay, so next, so I'm going to do is I'm going to convert my labels. Okay, I'm going to convert my labels into one-hot encoding. So basically, I have the row numbers of, okay, basically this is my class. For example, I got class 1, class 2, class 3, class 4, class 5. Class 1, the name is North. Okay, so when I change to one-hot encoding, basically I change to here. So for example, it should be 1, 0, 0, 0, 0. Okay, so this is direction north. Okay, I try to make it to become a binary, so it's easier for me to process later. Okay, and then the next step will be tokenize the text. So now, just now I'm tokenizing the label. So next I'm going to tokenize the text. So what the text tokenization doing is that first I'm going to find out what is the possible words, and then I'm going to assign it as an index, basically. Okay, for example, I have the index of hungry is 22 index, am is 23 index, and then hungry is 33. Sorry, 2 words repeated. Okay, here will be I should be 22, am is 23, and then hungry should be 33. Okay, in this case, so when I'm doing the tokenization, so I have I am hungry, so I'm going to change the words into a number. Okay, so like I am hungry, so it's 22, 23, 33. Okay, so this is how the tokenizer works. And then next, so because we have a lot of sentences, and each of the sentences is not don't have the equal length. Okay, so what I'm going to do is I'm going to use padding. Okay, so for example, I'm going to find the maximum one. So in this case, the maximum the length is 5. So for the first sentence, there's 2 left. So I just pad behind, which is 0 and 0 here. Okay, so this is basically padding. Because in order for you to training, you need to have a fixed input size. So what we're going to do is we're going to pad the place that where there's no text or there's no words. Okay, and lastly, I train and split the data into train and also testing. Okay, so besides that, you also can use like k-fold cross validation or bootstrapping. Okay, if your data is not enough. Okay, for me, I feel train test split is fine for me, so that's why I use this approach. Okay, so let's go back to our to our scripts. So yes, so the step 11 is I try to tokenize the labels into one hot encoding. Okay, and then next I'm going to tokenize the text. So for example, these sentences, what say? So the output for me will be 50, 89. Okay, and then also like we have, okay, I think this is too far already. Like summation u, oh, this is another sentences already. Okay, so this is the whole sentences. Summation u supply commercial grade to the experience tracking. Okay, so this is the whole text. Okay, so this is the functions of the tokenizer. Okay, after you go through the text tokenizer, then we are going to pad. Okay, so I set my length should be maximum 100, means the length, the column, okay, the number of the dimensions should be 100. So if less than that, the sentences, so you automatically pad with 0. So why I set my padding post means I add the 0 behind the sentence, behind the sentences. So if my padding is pre, means I put my sentence at the back, and then in front I add 0. Okay, so this means pre. So here I choose post, so mean I add 0 after the sentence end. Okay. And next I train test split. So basically I just split my data sets into training and also testing. And next I go for modeling. So for modeling, so I train using 2 models. So one is the MLP, so it's called multi-layer perceptron. Okay, and okay, the second one is called CNN. It's a convolutional neural networks. And how I evaluate the model, how do I know my model good or bad? So is I use the score of accuracy, the metrics of accuracy score, confusion metric, precision recall, and also the F1 score. Okay, and then so what is the so unique about multi-layer perceptron is that it only contains one hidden layers. Okay, it only contains one hidden layer, then we call as multi-layer perceptron. So if we have more than one hidden layer, then we call neural network. Okay, so we only have one layer, so it's called a multi-layer perceptron. And then for convolutional neural network, CNN, so basically it contains 2 parts. The first one is called a feature extraction. So it contains the convolutional layer and also the max pooling layers. Whereas for the classification is a fully connected layers. Okay. And lastly, I'm going to, yes, after I train my model, I evaluate my model, then I think, yes, it is okay for me to deploy. So what I'm going to do is I'm going to deploy my model and then do some reporting, okay, on my, the training score and also my validation score. At the same time, what text can really do is that you can show the words, okay, inside into a word cloud. So the word cloud is that the word is larger, means that it has a higher frequency, okay, in the words. Okay, so for example, here is that delay and also the back, okay, have a higher frequency. Has higher frequency in the negative sentiment. So that's why the word delay will become larger. Okay. So okay, go back to our codes. So just now I'm saying that we are going to model our data after we pre-process our text or our sentences. So the first is I import the library, and then next I basically do a function to plot my confusion matrix, and then next I define my functions, my network architecture. So if MLP, so basically we only contain one layer, one dense layer. So you can say that this one is a logistic regressions, or you can say it's a softmax regression, or you can also say that it's a multi-layer perceptron. Okay, it's all correct in this case. Okay, so I only contain one layers for this one. And for CNN, so basically I will have a convolutional layer, and then we have the max pooling layer. So at here there's 2 convolution and also max pooling layer. Only one. So one convolution layer and mean a max pooling layer. And then after that, I have 2 fully connected layer with different channel on size. And in between I add a drop out. So drop out here is to prevent the model from overfittings. Okay, after that, then yes, this is my model architecture for MLP and also CNN. Then after that, I train it with 5 EPO. Okay, so this is basically the result. Okay. Okay, so here so how we know our model performance is that actually, okay, I plot it into a chart. Okay, so if I plot into chart, I know the MLP, the best performer, okay, is is achieved the accuracy of 0.8484. Okay, whereas for CNN, it achieved 0.8536. Okay, so in this case, then I can conclude that actually CNN performed better, okay, a bit, okay, than the MLP. But the time taken for the CNN actually is longer than MLP lah. So if you think this small deviation is not really important in terms of accuracy, so probably you can take MLP, because as you can see, for training one layer, you will take 35 seconds, okay, for CNN, whereas for MLP, you only take 5 seconds for each layer. So you achieve almost similar result. So there's no point for you to have a longer training time and get quite a similar result. Okay. And then after that, I plot the accuracy. I plot the training. The history of the accuracy and also the validation accuracy score for it in each EPO. Okay, so this is roughly the graph, and then so this is the losses. Okay, as here somehow I think it's overfitted lah. Okay, because the validation is going up. Okay, probably you train at probably you only train for one EPO also. Okay, but this one is just for demonstration purposes lah. So if in the real application, you need to fine tune the model basically. Okay, and lastly, so I show the classification report, basically the precision score, the recall score, F1 score, and also the confusion metrics. Okay, and then we have the lastly I'm going to show the result as word cloud. So this is basically the result of word cloud. So I think I make it small a bit so that you can see the whole thing. Okay, so as you can see, for this one is for the negative sentiments. Okay, so you will see some words that is quite promising. The result, for example, the delay, back, cancel flight, and then what else? Delay again here. Okay, what else do I have? Wait. Okay, and then we have this tier word, this tier here. Okay, so this tier actually should not be here lah. Okay, because it looks like a stop word. So probably we need to include the stop word removal inside the operation into the text pre-processing. Then this word will be missing lah. Okay. What else? What can I say? Okay, roughly for this one, or late flight. Okay, you can see this. Okay. How about the positive sentiments? So you can see the words like thanks, love, amaze, okay, great, good, best, awesome. Okay, appreciate. Okay, so you're able to see this word in the positive sentiments. So this is the negative sentiment. So from here, probably you were able to know whether your model are really learning or not. Okay, so in this case, somehow for positive, I think it's learning. For negative, probably we still need to remove some stop words, okay, in order to make the entire the word cloud great. Okay, so I think I reached the conclusions. So today, I think I'm going through the process. So there are 4 steps, which is first is the business and data understanding, and second one is the data preparations. Then the third is the model training and evaluations, and lastly will be model deployment and reportings. So for the business and data understanding, first you need to set your business goal. You need to know what objective you want to achieve, and then how you collect the data. It's very important in real practical time lah, because here I download the data from Kaggle, right? It's actually I already collected, but in real cases, it's not. Okay, and then you need to know how to load the data and also explore the data using graph or other tools. And next, I introduce a lot of text processing techniques, okay, to clean the data, to transform the data, and also manipulate the data. And after that, I train the model using MLP and CNN. And lastly, I save the best model for deployment, and also show the result in the workload. Okay, so thanks for the session. Okay, so now it's Q&A. So I think you can, hopefully we have some time for the Q&A. So if you want to connect me, you can go to my LinkedIn or you reach me through Medium. Okay, and then actually I publish similar articles in Mediums, but it's more complicated because so at here basically I have more plot on the exploratory data analysis, and then after that I studied the accuracy between the the effect of the wordnet lemmontizer with post, without post, and different type of the stemming algorithm. And I also study the effect of whether before I augment my data and also after I augment my data. Okay, and then yeah, we still got RNN and also random forest. Okay. Okay. So yeah, this is the code for this medium. Okay, for this medium. Okay. So if you want to have the Google Colab script, you can go here. Okay, and then yeah, you want to know more about this, then you can go to this medium and read about this. Okay, so yeah, so I think I would like to have the Q&A session. So do you have any questions? Okay. Okay, I think I only have one question here. Awesome. Any recommended topic, books, link, website, coding, project, etc. to start? I think Kaggle is a very good place for you to start because you can get because the data set is ready. Then the second thing is you can, so how you can practice to win in the Kaggle is that first you should using your own approach, okay, to go through the data set, and after that you train the model by yourself by using your own technique, okay, and then after that you go to see how other people, because they got other notebooks or the public discussion, okay, so from there, right, so you can see how the people train the model and why they train, how they train the model, and then why they perform better than you, okay, than yours basically. Okay, so from there basically you can do something like this. Yeah, with the same step applicable to languages semantically different from language. For what I know, Chinese you got other concern. For example, like because Chinese word, all the words are actually stick together. Okay, all the words are actually stick together. So, no, sorry, the whole sentence, all the words are stick together. So you need an additional processing to split the word. Okay, so means like I cannot say in Chinese. Okay, so for example, yeah, those all the words will be stick together, and then you need an algorithm to split the tenses and so on. Okay, do you think it's good enough to use graph algorithm for NLP? Yes, this is definitely yes. So I read one paper. They saying that the current transformer, if you know what is transformer, okay, the current, the recent trend is more on the transformer, and the transformer actually they saying that it actually work like a graph okay, yeah, but you can use graph algorithm for NLP as well, if you know how. Oh, graph database. What do you mean? Sorry, I don't understand your question. Okay, but I interpret in this way that if you want to use graph algorithm for NLP, then I can say yes. Okay, but graph database, I do not sure what question you want to ask. Okay. Okay, so I think okay, open for another minutes. So if you don't have any question, then I would like to end this session. Okay, so it seems like there's no other question. So thanks for coming, and I wanted to pass the session back to the MC. Okay, thank you very much for attending this session. Okay, thank you.